Here's an example of section 13.1 using StatCrunch. This is pretty much what you need to know in section 13.1. Turkey farmer tests the three kinds of poultry feeds with the weights in pounds of the growing turkeys in each sample given below. Test at the alpha equal 5% whether there is a difference in the mean weights of turkeys consuming the different feeds. Assume the distribution are normal and variances are equal. Okay, here's how you set up the test. Your null hypothesis should be all the means are equal. mu1 equals mu2 equal mu3. It's always like that. And h1, it's always this statement. At least one mean is different from the others. And since it's asking us test whether there is a difference, so the claim is in h1. Okay, we're gonna put feed A, feed B, feed C in StatCrunch. Here it is. If you use a calculator, you put them in L1, L2, L3. In StatCrunch, you do the following, and then you go to Stat, you go to ANOVA, click on ANOVA, one way, select them. How do you select them all at once? You press down and hold the Control key, and that's it. You just hit compute, and you go right here for F statistics and the p-value. So F is 6.69 and the p-value is 0.084. If you use your calculator, you just put the data in L1, L2, L3 and run, go to Stat, Tests, ANOVA, and type in L1, L2, L3. I already have a video about that in my course shell and Moodle. So 6.69 and 0.0084. F is 6.69, step number 2, p-value is 0.0084, which is less than alpha. Alpha is 5%. So what's the decision? Reject HO. And what's the conclusion? There is enough evidence at the 5%. So if you reject HO and the claim is in H1, you support the claim of significance to support the claim that there is a difference in the mean weights of turkey consuming the different feeds. So this is how you use StatCrunch in section 13.1.